Hello and welcome to another video. In this video we're going to be doing LeetCode 1780, check if numbers is sum of powers of 3. I'm probably going to alternate between like problems of the day and system design, maybe more focusing on towards problem of the day and then just doing system design on my own until I get better at it because I don't want to make like hour-long videos. So for this one, given an integer, you want to return true if it's possible to represent the integer as a sum of distinct powers of 3, otherwise return false. And an integer is a power of 3 if there's this. So basically they tell you have to sum up distinct powers of 3 and you can only have one of each of these. So you can only have like one of these, one of these, one of these maximum, or 0. So for 12 it's possible because you have 9 plus 3. For 91 you have this guy. So I think this is like 81 plus 9, which is 90 plus 1, 91. And then this is impossible. So there's kind of two main ways to do it. They both make a little bit of intuitive sense, feel like a reasonable amount, so I'll kind of go over both of those. So the first is we can recognize that we can just go up to a power of 3 that's less than or equal to n. So like let's take this 91 example. We can just say like, okay, well, we're trying to get 91. So we'll start at like 1, then we'll go to 3, then we'll go to 9, 27, 81. And you actually have to use this number in the solution because if you don't, the sum of the rest, like if I have a number, if I have some power less than or equal to n, and I don't use that number, the sum of the rest is actually smaller than this number. So for 81, I have to use it, and there's no way I can avoid it. And with that logic, we can basically just keep checking what's like the smallest number or the biggest number we can use and just keep using that and see where our power goes and where our n goes. So what we do is we say, okay, let's use 81. Now we drop down to 10. Now let's take our power and keep dropping it until we get down to this number. So we're going to drop this, go to this, drop it again, and now we're here. And same thing, we have to use the 9 to have a viable solution. If we don't, everything else is too small. And you can see this would be too small. So we'll use the 9, then we'll have the 1. And then we just drop, and then we have the 1. And so going to that solution with 21, we'd say like, okay, well, we have 1, goes to 3, goes to 9, and 27 is too big. So we have to use the 9. There's probably some optimizations there. Like you can say like if your number is actually less than half the number or something, this is no way going to work. Because this is bigger than everything else combined. So you can just say they won't work. But let's say we just do use a 9, we don't realize that. So this will be 12. Now we just have the 1 and the 3. So we'll try the 3, this will be 9, and then we'll use the 1 and this will be 8, and then we can't do anything. So that's one solution, and basically yeah. The other solution is kind of using like binary. So like how do we, if we have a number, like let's say we have some big number, and we know it has like zeros and ones in binary, how do we know like how many zeros and ones it has? Well, we can just do bit manipulation basically. Where to get the last bit, we can just do and 1, or we could do mod 2. And then we'll get the last bit, right? So we'll have a number. So let's say our number is some random number. Let's call this x. So x is this. And now this mod 2 will give you this number. And then we can get that. So we can do the same thing with the 3, power of 3, right? Power of 3 is like you know, so this is binary. In powers of 3, every single bit will be represented as either 0, 1, or 2. So essentially, if we look, we have like an array. So this is like how many 3 to the zeros we have, how many 3 to the 1, how many 3 to 2, how many 3 to 3, how many 3 to 4, so on. So if we actually take this number, 91, and the easiest way to do is just take what's the biggest. So or we could actually go through this even. So 91, does it have this number at the end? So to find out what this number at the end is, we can just mod it by 3. So 91 mod 3 is just 1. So it is going to have a 1 here. And then like what's the rest of this? So the rest of it is we can just subtract this number and then divide by 3. 30. Now we can do the same thing. What's the number here? So the number here is this mod 3, so 0. Now I can do the same again, divide by 3, 10. So what's the number here? This is this mod 3, so 1. Then we subtract that number, divide by 3, you get 3. This is 0. Divide by 3, get 1. And here's a 1. So I think this is correct, so let's double check our math. So we have 3 to the 4th plus 3 squared plus 3 to the 0. And if we look at this, that's the same thing. So this is valid, but you're going to have some numbers that won't, like, if you represent everything base 3, this can be 0, 1, or 2. So let's say this is a 2. What would happen? Well, we know for sure this wouldn't work. So once we get to this and we mod it by 3, once we get to this digit and we mod it by 3, we're going to get a 2. So essentially, we just say, like, while n is greater than 0, mod it by 3. And we have to have either a 1 or a 0. So if this is greater, or if this is 2, then we return false. Then we can just divide it by 3. So you could use a subtract 1 and divide by 3, or you could do a floor divide. Either one's fine. Because, like, let's say we have 10. So we have 10. We could subtract 1 to make it an even number, or to make it a divisible by 3 number and then divide by 3. Or we could just do this and it's the same thing. So we can just floor divide. So that's kind of the second solution, and this is going to be log of the number, and it'll be over one space. So we'll go with that using kind of like the same logic as binary numbers, except this is base 3 numbers. And you should be able to figure out, like, okay, how do I get numbers in base 3, base 4? You know, they're not used, but it's the same exact concept. And, like, if I have base 3, then what can these digits be? If I have base 4, what can these digits be? And so on, right? And then you can check with those, like, okay, well, I know octal is base 8. So these numbers can be 0 through 7. I know, like, hex is base 16. This can be 1 through 15, decimal 1 through 10, and so on. So it's all the same kind of thing. All right, so we'll go with that solution. So we'll say while n is non-zero, if n mod 3 equals 2, then we know for sure we can't do this. So we'll just return false. Otherwise, we'll do n 4 divided by 3. And if we were able to make it, then we can return true. Okay. So hopefully this makes sense. Hopefully the other solution makes sense. Like, I think it's kind of intuitive the way I explained it, where you can take the biggest number that's less than or equal to n, and you have to use that number. Hopefully it makes sense why, and so on. And that's another one that works. So I do think this is, like, not a hard problem to do once you recognize these things, but it's not super obvious. All right, so runtime. So essentially this is like log n. This is log base 3 of n, basically. And space is constant. So let's see what our thing is. Did it just copy? Yeah, so log n constant. All right, so that's going to be all for this one. Yeah, probably going to be doing more daily problems and then do system designs on my own until I get better at it, and then I can do, like, deep dives and all that kind of stuff. So yeah, that's going to be it for this one.